Ross and I both kind of tag teamed this work in this release, so I invited him to collaborate on this talk. So we're going to talk about the changes in the Python recipes and classes and everything that landed in the 4.0 Kirkstone release. So I'm Tim Orling. I work for Yocto Group, and I'll let Ross introduce himself.
Hi, I'm Ross Burton. I'll just skip forward a few slides. I work for Arm Limited, Principal Yocto Engineer is my official title, which is quite cool. Previously Intel, previously Open Hand. I still don't consider myself to be one of the old guys in Open Embedded, but my first commit was in 2005. So maybe that does make me one of the old guys. Tim, shall we go straight? Do you want to do your full introduction, or shall we go straight into it?
You're still on the first title slide. Do you want to go to the next one?
Yeah, that one.
Hasn't changed yet for me.
Love it when Zoom works.
There we go. Okay, so
I need second.
Yeah, so I work for Yocto Group. We're a services company. We do lots of stuff in embedded Linux and open source software, U-boot and all kinds of other things, a lot of work on AGL and so on. We do hardware and software design and development and training. So we are based in San Jose, California, but we're actually very much global. And you can check us out at consulco.com.
So
go ahead. You go ahead.
So basically, a quick agenda. Talked about what has happened upstream in Python, what they have deprecated, what the replacements are, what we've done to handle this, and then talking about the extra pain of Rust and Python together. Here we have we've messed up the ordering. This is Tim's introductory slide.
Yeah, so I'm somewhat famous for Python in this community, and I created MetaPython back on a sabbatical in July of 2014 from an apartment in Costa Rica.
Living a dream. Obviously, the slides weren't working earlier. This is my first commit back in 2005 to what at the time was called Pokey. I'm very disappointed with my commit message formatting. I'll be quite upset. I'll reject that now. Anyway, so there's been a big change to Python packaging over the last year, leading to lots of people having questions like, where's setup.py gone? Why can't I use distutils? And what are all these new classes in the latest Yocto release? We mainly blame Python Enhancement Proposal 517 for this. It's a build system independent format for source trees. This is a complete change to how Python is built. Well, Python packages are built. Typically, they were based around a setup.py file, which called a built-in Python module called distutils. You normally just run setup.py install, and that uses the distutils API. Normal users these days just use pip, but that calls setup and expects it to be using distutils. Distributions like Yocto and pretty much every other distribution, we still care about dependencies and where files actually end up. So we control the environment ourselves and call setup.py directly. Underneath all of this is the distutils API. This was added in Python 1.6 22 years ago. It hasn't aged particularly well. There's feature creep, undefined behavior, private APIs, which are now used by everyone. Setuptools actually embeds a copy and used to just monkey patch the existing copy in Python at runtime, which is fun. Distutils also hasn't been maintained since 2014. They've been telling everyone to move to setuptools, which is maintained as a separate project, so it has a lot more freedom to evolve over time. Finally, in Python 3.10, which was released October 2021, they deprecated distutils. This means it'll be removed in 3.12, which is due October 2023. That's 1.5 years away. The Kirkstone release is an LTS, so we really wanted to be sure we supported all this stuff now, instead of not making the LTS release and suffering in 18 months' time. So the first step was making sure that no one was using distutils anymore and porting over to setuptools. Luckily, porting is fairly trivial. Patches like this are absolutely fairly standard. Active projects tend to have done this already, so you just change your inherits. We sent a lot of patches upstream to projects which hadn't yet got around to it, and we're carrying a few patches for packages which are basically dead, but we still need. There are some edge cases where this doesn't work, and they tend to be very good examples of why distutils is a terrible idea. So there's a couple of users still, and they are not in a good place. So that's why distutils is being deprecated. What's the future? What does PEP 5.17 bring us? So PEP 5.17, the entire point is that it's build system independent. You kind of need to know what this means and how it works if you're going to write a recipe. So I just go over some rough basics of it. It defines a very minimal build API with a much tighter scope compared to distutils. It is also explicitly targeted at installing a Python module, not code which just happens to be written in Python. The build API is based around a pyproject.toml file. TOML files look very much like an old ini file, but for some reason you need a new parser. This can contain a build system section, and that should tell you which package is required to do the build and what class implements the build backend API. In this case, flitcore is the package, and to do the build, you just call flitcore.build API. The backend interface just has two methods that are required. There's a few others, but we don't need to go into those. Build will and build sdist. We only care about building a package, so we just need to call build will. The API is explicitly very slim. As long as a will appears in the specified directory, the API doesn't care what happens. Configuring the actual build is entirely out of scope. Pip knows how to do PEP 5.7 builds already, or there's a slimmer tool called build, which just does one job well. It sets up self-contained environments, checks for dependencies, does the build, and spits out the will. So for to normal users, build is a good way to go in the future. A will is defined by another PEP. This is 427. It's a binary package format for distributing Python modules and ancillary files such as documentation, data, scripts. It's basically a zip file with a well-defined structure inside it. I'll say again, it is designed for installing Python modules. It cannot be used to install arbitrary files. Wills are fundamental to the new system, and as they can only be used to install Python modules, you can't just use this system to install code which happens to be written in Python. There's a lot of packages which are written in Python and use distutils to install now and drop systemd units and man pages and all sorts, and this will not work with the new build system. They need to move to something like Meson, something which is more generic. Again, pip can install wills. There's also a package called installer, which does one job well. It knows how to install a will. For bootstrapping, you can just unzip them, which is refreshingly simple. So this is the complete workflow for building a package. You get your source code. In an ideal world, you run it through the build tool. Thanks to bootstrapping pain, which Tim valiantly battled with for far too long before realizing, I think, that actually it's an unsolvable problem at the moment, and it continues to be unsolvable. We can't use that, so we currently just call the API directly. It's trivial. It covers most of the use cases, and that generates a wheel. We then can use the installer package to splat the files into the sysroot, and then everything is as usual, as Yocto expects. Bitbake can pull the pack files out and build the packages. We will be moving to use the build tool in the future once they've sorted out the bootstrapping story. It is getting there, and it does give you some nice features. It does dependency checking. It can do self-contained builds, but we don't care for those. But mainly, the dependency validation is very useful, and not having to just, the more code we can palm off onto other people, the better. So what do we have in Yocto to support this glorious new world order? So for a start, there's the Python pep 517 class. This is a abridged form. There's the decompile task, which just uses the native Python to call the right API and build a wheel. Then there's the install task, which uses the native Python to run the installer and install the wheel in the dester. This is nice and easy. We currently need to specify the API itself, which is suboptimal, but this is a short-term solution. This will be fixed shortly. This is nice and easy, but don't use this class. If you're using this class, you are doing it wrong. Recipes, if you're writing a recipe, look at the class. Look at the recipe. Look at the code, find your pyproject file, and see what build system it uses. So in this example, it's using flickcore. If the pyproject file doesn't exist, or it doesn't have a build system section, then it doesn't use the new build systems. It's probably still using setuptools or distutils. So this is all irrelevant. So the previous class was, you said it uses flickcore. So you can then inherit the Python flickcore class. And we also have classes in core for poetry core and declarative setup tools, which is where all the build configuration is in a setup.cfg, and there is no setup.py at all. That, despite still being setup tools, is PEP 517 compliant. All of these classes are trivial. They just inherit the Python PEP class, set depends, and the entry point. It's really quite simple. So if you're packaging a recipe and someone has upgraded, well, they've ported from setup tools to, say, flickcore, the recipe port is as easy as you'd hope. You literally just change the inherit. There may be some tweaks that are needed for recipe to clean stuff up. But if Upstream have done the work, then it should just be trivial. Often you'll find recipes get smaller because the builds are now more reliable. You don't need to work around bugs in distutils. If you try porting a recipe and it doesn't just work like this, then obviously, come on IRC, ask the mailing list. There's plenty of people around to understand how this works. Ping me or Tim, and hopefully we'll help. So if you want to read more of the background to this, then you can start with the PEPs, and all the PEPs they reference, they accumulate. There's probably about 10. Not recommended. There is a blog series called The State of Python Packaging, which is actually quite interesting and goes into the history and what's going to happen in the future. So that's actually a good read. I do recommend that. And that's everything about the PEP world. So I'll hand back over to Tim for the Rust side.
Yeah, and I will say that out in the wild, distro folks and the Jupyter and Anaconda folks and so on, you really have to carefully explain to them the world we live in, because they do not understand why we can't use what they've produced. So it's been an interesting journey.
Yeah.
So the one other thing that came up in the world of Python, I forget how long ago, but suddenly Python cryptography, which is kind of an important thing, started using these new Rust extensions for Python. So I spent a lot of time on this as well as I spent on all of these topics. So the basis of the Rust extensions for Python, there's this Pyo3, Python trioxide, there's a play on words, group out there. So it's on GitHub, and I recommend looking at these different links and finding out more about it. And one of the things that they did was they used setuptools extensions to add the capability of using Rust language to write Python extensions, instead of before we only had C, basically, right? So setuptools Rust is a plugin for setuptools, right? And it allows it to compile typical Rust things that have, cargo, toml, and all that kind of stuff. Go ahead. So, we're always trying to reuse things and keep things compartmentalized. And so the basic of all of this is this Pyo3 class. And also in this release, we decided to namespace all of these classes with Python _ before it. In the past, we just had setuptools 3 and all these other things, which to those of us that use this every day, it all made sense, right? But we wanted to make it very, very obvious this is about Python. So the things that the Pyo3 class does, it inherits the cargo class, and it sets these different variables that basically are needed to tell the Rust tooling how to build Rust for native or for target. And it basically has a do configure that writes out some special stuff into a config file that we pass into Pyo3 as it's being built. Go ahead. So then the Python setuptools Rust class inherits from Pyo3, but it also inherits the somewhat legacy setuptools 3 method. So right now that means this is building the old style eggs, not wheels. That's something we'll have to figure out as things mature. And it has a do configure method, which maybe you haven't seen this or haven't realized that this needs to happen sometimes, but we actually need to call multiple different classes do configure in order to have everything happen. And so it turned out in this case, first we had to set up the Rust variables and everything that the Pyo3 needed to know about. And then we call cargo common to do the cargo Rust, language specific configuration. And this is where most of the magic for target is occurring. And anything that's broken is possibly, something broken in just normal Rust handling and not something specific to Python. And then we have to call the setuptools 3 do configure to set up the actual Python packaging and everything like that. Go ahead. So the first example of this, the whole reason that we had to do this is because Python cryptography had changed, and it's been changing since. The first iteration, it actually didn't have any Rust code, but it required setuptools Rust. The key thing here is as you may have seen in other talks, that the best way to use Rust in Yocto Project is to use the crate fetcher. And what this does is it sets the Rust build environment up in a directory that we control, that we know about, we know where everything is. So one of the things you need to do is you need to populate the source URI with all these crate URLs. And this took me quite a while to understand and figure it out. And I had done it the other way, right, where it's not in a directory controlled by bitbake. Absolutely, this is the way to go, 100%, no doubt about it. The only problem is that in order to get all these crate URLs, you need to get it from somewhere, and the tool out there that does that for us is Cargo Bitbake. And it's great at it. It creates a basic skeleton recipe. So if you look at your Python module, there's usually a source directory or something like that that has a cargo.toml in it. And so you run Cargo Bitbake on that. And then all we do is just grab the crate URLs out of that and paste it into the source URI. And then we call, in this case, right, there's not even a source URI for the URL for the actual PyPy, right? Because we're inheriting PyPy. So that really, really simplifies Python recipes. And then we call Python setuptools 3 Rust to, actually that doesn't have a 3 in it, does it? Anyway, that's a typo. To actually do that. And this is basically what's in this recipe. There's not much more to it. There's another example out there in Meta Python called pyruvate, just so that I had more than one to test the tooling. Very, very few things are doing Rust extensions right now, but Python cryptography is important enough that we actually moved it into core, even though that's given us some growing pains. But that's basically it in a nutshell about the Rust extensions and how they're used. So the next steps, what we're going to try to do next, we really need, so recipe tools and dev tool have been kind of limping along in terms of Python recipe creation. I forget who it was that actually upgraded us from Python 2 to Python 3 a couple of releases ago. But now those tools are all entirely based, it's really recipe tool itself. It's entirely based on assumption that you have a distutils backend around, in your source code, and that's not true anymore, right? Because distutils is deprecated. And even depending on having a setup.py being present is a bad assumption now. As Ross said, there's certain things that are going to require setup.py going forward or something else going forward because they're installing executable scripts or other things that are not a Python library. So we need to incorporate all these new classes and the new recipe styles and all of that stuff into recipe tool. And then dev tool usually benefits from that. The other thing is there's another tool out there called Maturin. This is really where the work is happening. It's no longer happening in setuptools Rust anymore. And it's a little bit more for Rust-centric applications, but it's aware of Python and Rust and Cargo. So if you go and look at these two links, you can see a little bit more about that. I've already written a recipe for this. The recipe was very straightforward, but I don't have any use case for it yet. And so for that reason, I haven't submitted it or tried to do anything with creating a class or anything like that. This world has just been changing so rapidly, and thankfully Ross came in after I did a huge amount of work, and he cleaned up everything and made it much more Yocto clean, and got rid of some assumptions and things like that I had done because I was just trying to make it work as fast as I could because we had to get this in for the LTS or live with none of this stuff working for 2 to 4 years. So thanks everybody that helped get these changes across the finish line. There were a lot of you that helped with this. And I also really thank Richard for being willing to take this at the last minute. The reason it came in at the last minute is I couldn't get the work done until then, right? And it was never planned to take so long, but it did. And I really thank Ross for coming in. His second set of eyes and all the refactoring he did was just absolutely invaluable. And we're a proven team in that regard. Meta Acorn's another example of that. So I'll let you take us out, Ross.
Yeah, it was definitely an experience working on the new classes. It was a terrible timing. If they decided to change the world when it wasn't an LTS release, we would have taken a lot more time over it. So yeah, that's the presentation. Thank you very much, everyone.